Okay, my name is Ansley Benjamin. I'm going to be showing you my circuit code for my window robot. And so for context, I'm building a rectangular robot that's going to sit on four wheels powered by DC motors. There's going to be a compartment inside with cleaning solution. It's going to have a pump that's going to be represented by a DC motor that's going to feed the solution up through the arm to the squeegee. The squeegee is going to dispense them via these holes. It's going to have a distance sensor on top to measure the height of the window and the cleaning area. And then this is the photoresistor at the bottom that's going to detect light. So here are my DC motors. These are the top um, wheels, or I'm sorry, the front wheels. These are the back wheels. This is going to be the pump DC motor. It's going to go through a transistor and a resistor. To basically control the amps to make sure that the circuit doesn't get overloaded. Same thing here with this photoresistor. It's going to go through a resistor. This is a distance sensor. It's going to detect that window distance. And then these DC motors have to go through what is called an H bridge to basically just organize the outputs and such. And then here is the servo motor that's going to control the extendable arm. And so here's the code. Um, Up here, I'm just declaring and importing like the servo motor for the cleaning arm, the trig and echo, the input output for the distance sensor, the wheels, assigning them to pins, and then the light sensor. It's going to go through an analog because it's an input, so it's going to be A1, and then here's some values that I need. Like light max is going to let me know that light is present. Distance max is going to be the max height of the window. Distance threshold is basically going to be the distance up into the window seal. That's going to commence the cleaning process. Here's the setup, basically initializing all of those, letting them know what I need to do. These are my cleaning methods, basically. This is going to be the cleaning methods, and then here's the distance calculation. I'm converting to inches, and then here's the loop. It's going to say if there's no light present, then I want you to keep looking, keep moving forward. But if there is light present, then I want you, if the distance is past a certain point, I want you to start the cleaning cycle. So let's go ahead and run this. As you can see, light's detected, or I'm sorry, light is not detected. So these motors are just going to keep going. And they're going to move forward, look for light, stop, move forward, look for light, stop. They're going to keep doing that until light is present. So notice that the cleaning doesn't start because there is no light detected, so they're not at a window. So now we're going to detect some light. And as you can see, because we're past that threshold, it's saying, okay, we actually got lucky and we're actually at the window now. So now the cleaning process is going to start. It's going to extend that arm up to the top of the window. And then when it gets to the top, you can see this motor is going to start right now. It's going to go for 3 seconds, and that's basically going to spray the solution at the top of the window. Once it does that, this is going to then, the servo motor is going to retract. The wheels are going to turn right. It's going to travel the distance of the squeegee width, and then it's going to repeat until it runs out of space, and then that is when it's going to be done cleaning that window. So let's just say, for instance, um, that we do that and we are not at the window yet. Um, So if we detect light, but we're not at the window, everything still stops, but the cleaning process doesn't start because we're underneath that threshold. So light's detected, but we're not at the window yet. So now we do get there, right? And light is detected. And now the process starts. So that is my code. Thank you so much.